obtain the general solution of differential equation x squared dy dx equals to x squared plus 2xy plus y squared. The equation is on the board. They want us to obtain the general solution of this equation. X squared dy dx equals to x squared plus 2xy and then plus y squared. Solution now, we shall divide through this equation by x squared so that we will remain with dy dx equals to x squared plus 2xy plus y squared, then all over x squared. Then after dividing through by x squared, you can see this is the differential equation where we need to use substitution in order for us to be able to get the general solution of this equation. So we shall substitute by y equals to Vx. Now when you substitute y equals to Vx, first of all, we differentiate now y with respect to x, so that we have dy dx. Now to differentiate this equation, we apply the product rule. We put down the first, which is v, and differentiate the second, which is x. So when you differentiate x with respect to x, you get 1, then plus. We put down the second, which is x, and then we differentiate the first, which is v, with respect to x. So when you differentiate v with respect to x, you get dv dx. It means that now dy dx equals to v plus x dv dx. Okay. Now this is dy dx. So when there is dy dx, we replace with v plus x dv dx, and where there is y on this side, we substitute with vx. Therefore, our equation then becomes dy dx is v plus x dv dx equals to, now we have x squared plus 2x into, when there is y, we substitute with the vx, then plus over x squared. Over x squared. Now this equals to x squared. We open up the bracket, we have plus 2x squared v plus v squared x squared over x squared. Now we can factorize out. So we have here v plus x dv dx equals to, we factorize out x because it's common, x squared into 1 plus 2v squared plus 2v here like that. We can cancel x, so that we remain with, this was 1. When we factorize out, we remain with the 1. 1 plus, that's 1. So we have 1 plus 2v plus v squared. So what we are saying is v plus x dv dx equals to 1 plus 2v plus v squared. Now from here, v now crosses to the other side, so we have x dv dx equals to v squared plus 2v plus 1 minus v. When v crosses to the other side, becomes negative, so therefore this equals to v squared plus v plus 1. 2v minus v remain with the 2v. Therefore here we have v squared plus v plus 1. Therefore we are saying x dv dx equals to v squared plus v plus 1. Now from this equation we need to separate v and x. So we shall divide through by x. We divide through by x and multiply through by dx and divide through by v squared plus v plus 1. Okay, so when I divide through by x, then I have dv dx will be equal to v squared plus v plus 1 all over x. Then I multiply through by dx. dv equals to v squared plus v plus 1 all over x, then dx. We have multiplied through by dx, and then we divide through by v squared plus v plus 1. Therefore, I'll have 1 all over v squared plus v plus 1 dv equals to 1 all over x, then dx. So at this point, I have now separated x and v. Now, we now integrate both sides of the equation. So here you should have the integral of 1 all over v squared plus v plus 1 dv equals to the integral of 1 all over x, like that. Now when you integrate 1 all over x, you get ln of x. Now we want to integrate this. We want to integrate this. Let's work it out there. The integral of we want to integrate that. Now we can write this denominator as v plus a half squared. So when you open up this bracket, this will be equal to v squared plus 2v dot a half plus a half squared. So this equals to v squared plus this will be now v, 2 and 2 will cancel, so we have v, then plus 1 over 4. Now when you compare this and this, they are the same, and then here this is 1. So for us to make sure that this is 1, so remember this is 1 over 4, so we need to add 3 over 4. So if that is the case, then we shall have the integral of 1 over v plus a half squared plus 3 over 4, then dv. So this is the same as this, in that when you open up the bracket, we shall get 1 over 4 from here, then we add on this, which will make it 1, which is 1 over 4 there. So this is correct. Now, I'll rearrange this one as the integral of 1 over 3 over 4 plus v plus a half squared dv. Now, this is the integral of 1 over, now I'll have 3 over 4, I factorize out 3 over 4, 1 plus, but then here I'll have 4 over 3 into v plus a half squared dv. I've introduced here 4 over 3 so that when you open the bracket, this will cancel and then you remain with that one. So I've not changed the equation. But then, so I can take out 4 over 3 because it's a constant. So here I would have 4 over 3, the integral of 1 over, now here I remain with 1, plus, then I want to take 4 over 3 inside the bracket, so I take the square roots. Get the square root of 4 and 3, and then you multiply through the bracket. So the square root of 4 is 2, the square root of 3 is root 3, therefore I have plus 2v root 3, then plus, now the square root of 4 here, it will be 2, the 2 will cancel with the 2, and then I remain with 1 over root 3 plus 1 over root 3, then squared, then dv. Now from here, you realize that this one, I can now modify this one so that I can get the arctan of this function. So we have this will be 4 over 3. So if I want to have 2 root 3 to be the numerator, so I need to modify this expression so that here I have 4 over 3, then I have 2 root 3 as the numerator, but then I modify this so that outside I have root 3 all over 2, so that when you remove the integral sign, you still have 1. When you multiply inside by root 3 all over 2, to cancel this, but here and then I have 1 plus 2v root 3, then plus 1 over root 3 squared dv. Now this equation, therefore, when you integrate this, therefore here we have now, and this will be the same as 2.24 is 2 times 2 all over root 3. 3 is the same as root 3 times root 3 dot here I have root 3 all over 2, and therefore when you integrate this now, you get arctan. You get arctan of 2v plus 1 over root 3. So, but these two will cancel that 2. This root 3 will cancel that root 3. Therefore, will remain 2 all over root 3 arctan of 2v plus 1 all over root 3 equals to now ln of x plus now a constant of integration. So once we are through the integration, then we add the constant of integration. So the general solution would be 2 root 3 arctan 2v plus 1 all over root 3 equals to ln of x plus a constant of integration. Thank you for watching and listening. Thank you.